Hello, welcome to GP Podcast.
So let me ask you something. What if the very foundation of our entire digital world, the engine that powers everything from your phone to artificial intelligence, what if that engine is about to be completely upended? Today we're diving into a story of immense complexity, staggering cost, and a tiny startup that's trying to rewrite the rules of physics and manufacturing. You see, for decades now, the world of advanced chip making has really been defined by just two giants. On one side, you've got TSMC. They're the Taiwanese powerhouse that manufactures something like 90% of the world's most advanced chips. And on the other side, a Dutch company called ASML, and they have a total monopoly. They build the only machines capable of printing those chips. It's this delicate, incredibly profitable balance. And right at the heart of this entire industry is something called the EUV lithography machine. I mean, this thing is arguably the most complex tool humanity has ever created. And its job? Well, its job is to print these microscopic transistor features onto silicon wafers. That one single step, that defines the future of all computing. So you're probably wondering what the price tag is for all this complexity, right? Well, a single one of these machines from ASML, it costs around $400 million. Just to put that into perspective for you, that's more than a Boeing 787 Dreamliner. It's an absolutely staggering investment, but it's the one that underpins the entire trillion-dollar tech industry. And this is where you get this incredible paradox of modern manufacturing. This colossal machine, I mean, it's the size of a city bus, is somehow tasked with creating features more than 10,000 times smaller than a human hair. To do that, it has to blast these tiny molten tin droplets with lasers inside a near-perfect vacuum. It is an absolutely incredible feat of engineering. Okay, but here's the catch. There's a problem. Even this miracle of technology is hitting a fundamental wall. You've probably heard of Moore's Law, right? The idea that chips just keep getting smaller and more powerful every year. Well, that relentless march is kind of running out of road. And the limit, well, it's light itself. So here's the crucial point, and it's pretty simple physics, really. You just can't reliably print something that's smaller than the wavelength of light you're using to print it. The industry already made one massive leap, going from what's called deep ultraviolet, or DUV light, to the current standard, extreme ultraviolet, or EUV. And that jump to a much, much shorter wavelength, that's what unlocked the chips we all use today. But here's the thing. Now, even EUV light is too thick, for the tiny features we need. So the industry uses this really complex workaround called multi-patterning. Just imagine trying to draw a super fine grid with a big, fat marker. You can't do it, right? So instead, you draw every other line. Then you shift your paper a tiny bit, and you draw the lines in between. It works, but every single pass adds more time, more cost, and a huge risk of tiny defects that could ruin the whole chip. And you can see where this is going. This workaround is becoming economically unsustainable. The current advanced EUV machines, they're already approaching $500 million each. And get this, by the end of the decade, a single factory, what they call a fab, is projected to cost $50 billion. I mean, at that point, advanced chips just become inaccessible for almost everyone. So this all brings us to a pretty radical question. What if everyone is solving the wrong problem? What if the future isn't about making an insanely complex process even more complex, but about finding a completely different way to print? And that's where our protagonist finally enters the story. It's a tiny US startup called Substrate, and they are making a colossal bet. See, they're not trying to improve EUV, they're abandoning it entirely for an idea that the industry basically left for dead decades ago. Their bet? It's on something called X-ray lithography. Now, X-rays have a much, much shorter wavelength than EUV light, which in theory makes them perfect for printing tiny, tiny features. The idea has been around for ages, but it was always considered just impossible for mass manufacturing. So what was the problem? Well, the main roadblock was always the light source. For the longest time, the only way to generate stable, powerful X-rays was with a synchrotron, which is basically a particle accelerator the size of a building. Obviously, you can't just stick one of those in a chip factory. But over the years, the underlying tech got better and better, and Substrate claims they finally cracked the code, that they've shrunk all that power down into a single, factory-ready tool. So, okay, how does printing with a whole new kind of light actually change the game? Right. This is probably the best way to think about it. The current EUV process, with all its complicated multi-patterning, is kind of like sketching a complex drawing one set of lines at a time. X-ray lithography, on the other hand, with its incredibly short wavelength, aims to be more like a stamp, imprinting the entire design in one single clean exposure. And let me tell you, Substrate's claims are bold. They say they've already demonstrated printing features that are relevant for the next generation of sub-2 nanometer chips, and they did it all in a single pass. They claim a resolution that rivals ASML's very best machines, which is mind-boggling consistency. But here's the real kicker. They believe their tool could cost about a tenth of an advanced EUV system. We're talking maybe $50 million instead of $500 million. Now, I know, this all sounds completely revolutionary, but inventing a tool in a lab, that's one thing. Competing in the brutal, unforgiving world of high-volume chip manufacturing, well, that's an entirely different challenge. This is where our story really pivots from physics to the harsh, cold reality of economics and scale. But, here's maybe the most surprising part of their whole plan. Substrate doesn't actually intend to sell these machines to TSMC or Intel. Nope. Their ambition is much, much bigger. They want to build their own factories, using their own machines, and compete directly with the giants. They're not just inventing a new tool, they're trying to invent an entirely new factory, a new foundry. And to do that, they have to go head-to-head with TSMC, which, as you can see, has a 90% stranglehold on this market. This isn't just about having better technology. It's about trust, reliability, and decades of accumulated expertise that huge customers like Apple and NVIDIA absolutely depend on. And the difference in scale is it's staggering. Look at this. TSMC runs around 30 factories, and they pump out over 1.5 million wafers every single month. They have spent decades perfecting thousands of tiny little steps in their manufacturing recipe. Substrate, on the other hand, has to build all of that discipline and knowledge completely from scratch. So this really brings us to the final conflict, the central question. On one hand, you have the incumbent technology, EUV, being pushed to its absolute physical and economic limits. And on the other, you have this challenger, X-rays, that promises a simpler, cheaper path forward, but it's facing a near-impossible climb. What makes Substrate so fascinating is that their goal is total disruption. See, other startups, they're trying to build, say, better light sources to help ASML's existing machines go just a little bit further. Substrate is trying to make those $500 million machines completely obsolete. It's a real all-or-nothing gamble.
And that leaves us with the ultimate question, doesn't it? Are we witnessing the quiet beginning of a whole new era in computing? One that breaks the monopolies and makes powerful chips accessible again? Or is this whole thing about to become a very, very expensive lesson in just how unforgiving and difficult the business of chip manufacturing truly is? If you liked the video, subscribe, leave a like, comment on what you liked most, and share the video.